In this video, we're going to go through a piecewise word problem. So it says a plane descends from 5,000 feet at 250 feet per minute for 6 minutes. Over the next 8 minutes, it descends at 150 feet per minute. Write the piecewise function that models the scenario, and then what is the altitude after 12 minutes? So first, hopefully it's a big giveaway that it says write the piecewise function, that you're going to have a piecewise function, but I need to define what my variables represent. You can use whatever variable you want. A lot of people will use t here. I'm going to use x because I'm not very creative and I like to use x. But I'm going to say x is the time in minutes. Then I get to say f of x is going to be the plane's altitude, the height of this plane after whatever time. So I'm going to end up with a function, f of x is equal to something like this. I'm going to start off with this first sentence. We are starting off at 5,000 feet, okay? So I can just start off at 5,000 feet. But then I'm going to descend at a specific rate. That is my slope. Okay, so I have 5,000 minus 250x. I could have negative 250x plus 5,000. It's the same thing. But that's the equation I'm going to use when 0 is less than or equal to x is less than or equal to 6, because we're going for the first 6 minutes. The second sentence is what's going to help us figure out the next part. But there's a trick here that many people are going to miss, and it's very, very simple to miss. We're not starting at 5,000 feet anymore. We've already descended for 6 minutes. So if I look at f of 6, I have 5,000 minus 250 times 6. 250 times 6 is 1,500. So I'm going to have a height right now of 3,500. Okay? I'm not going to start writing it in here, and you'll see hopefully why in just a little bit. It is kind of tricky still. But I'm going to have a quote-unquote starting height of 3,500. For the next 8 minutes, we are going to descend at 150 feet per minute. I don't get to just put minus 150x. I have to put parentheses x minus 6. This is extremely important because when x is not in this red domain, it's going to be bigger than 6. So I'm going to be plugging in this time frame of when the time is 7 or 8 or 9. But I'm going to multiply that value by negative 150. In the time from minute 6 to minute 7, that is 1 minute of descent. I don't want to multiply by 7 minutes of descent. Hopefully that makes sense. It's kind of a weird thing to kind of wrap your head around without fully just kind of going through the process a little bit at a time. So to make sure that I'm multiplying by 1 for 1 minute at this speed, 2 for 2 minutes at this speed, 3 for 3 minutes at this speed, I'm going to take the time of the overall time, subtract 6 to get into the right domain. But now, because of that parentheses, I have to simplify a little bit. So I'm going to distribute. I am going to get a minus 150x, but I'm also going to get a plus, well, 150 times 6 is going to be 300 times 3, 900, plus 900. Okay, and that's going to give me 4,400 minus 150x, and that's what's going to go in here. Okay, same thing as before. I could have negative 150x plus 4,400. But now my domain is going to be 6 minutes, not including that, is less than x, is less than or equal to 14, because 8 minutes later will be at minute 14 overall. I am going to be plugging in, like when x is 8, for example, I'm going to be plugging that in times 150, negative 150. But because of this distribution, this plus 900, which changes this number to 4,400, it kind of compensates for the fact that we were descending at a different rate previously. So now, when the question says, what's the altitude after 12 minutes, I just get to plug in f of 12, which puts me right here. 4,400 minus 150 times 12. Well, that's going to be 300 times 6 is 1,800. So 4,400 minus 1,800 gives me a value of 2,600 feet. Okay. Now, a faster way of doing this problem specifically, keywords, this one specifically, we had 6 minutes of a descent of negative 250. We had 6 minutes of descent negative 150. Okay, that's how we get to our 12 minutes. This is essentially 6 times negative 400, which is negative 2,400. So over the 12 minutes, we went down 2,400 feet. Subtract that from 5,000, and we're golden. But these numbers right here are very, very nice. If I asked you to do this for what happens after, we'll say, 11 minutes and 45 seconds, this process that I just outlined here for a quick check is going to fall apart very quickly. It's going to be very, very difficult to do. Well, if I said 11 minutes and 45 seconds, that's 11 3/4 minutes. I can plug that into my piecewise function, and it takes care of itself right away. The piecewise function makes the overall problem simpler. It doesn't make every part simpler, which is annoying. I get that. But it makes the more annoying pieces easier to work with. So that's why we want to make sure we're able to understand how to write these piecewise functions. Okay, they're a tool to make our lives a little bit easier. Have a great day, everybody.